Hi everyone, welcome to our channel. Today we are going to solve the valid parenthesis problem. Also, we will be comparing the code for the longest valid parenthesis problem with the present problem because most of the parenthesis problem are just variation of each other. So let us see this problem. The problem says that given a string S containing just the characters, so the characters are this inside the string. So we can see that there are three types of brackets in this. And the next thing is determine if the input string is valid. And these are the conditions for valid. So let us read them. Opening brackets must be closed by the same type of bracket. So this means every opening bracket should have a closing bracket. Opening bracket must be closed in the correct order. So this means if there is opening bracket, then it should have same type of closing bracket just after that. We can see in this also there is an opening flower bracket, so we should have corresponding closing bracket to that. So let us see some more example of valid parentheses in the next step and get some inference from them. So these are some of the examples of valid parentheses, and in the example one we can see that there is an opening and closing bracket, and that is of the same type, so that's why it's true. Now going to the second example, yes, every bracket has its own type and none of the bracket is left uncombined. So that's why that's also true because it's in proper order. Now going to example 3, you can see that although the opening although the opening bracket of this type, but we have closing bracket of this type. So that's why it's not of the same type. That's why it's not valid. So that's why the answer is false. Now going to example 4. In example 4, we can see that there is an opening bracket and again opening bracket and then there is a closing bracket. So we have to check if this corresponding opening bracket is same with this closing bracket. Yes, it's valid. Then we can see there is one more closing bracket. So yes, we have a opening bracket similar to that. So this means the opening bracket we have to store and keep it, and as soon as we get closing bracket we have to check with them and with the recently bracket that we have encountered. So this means we need some kind of data structure to store all the open brackets. Now in the example 5, why it's false? Because there is opening bracket, again there is opening bracket. Although the opening and closing bracket is same, but the combination is not valid because there is a red bracket. So again we should have red bracket. So that's why the yellow should be with this. That's why it's not a correct valid combination. So that's why it's false. Now we can see various inferences in this. So in the next step, let us note down this inferences. So these are the points that we have noted down. Now the points are store the previous opening bracket. So we can see in the example 4, we need previous opening bracket so that we can compare it with the current closing brackets that we are getting. So that's why we need to store it in some data structure. And then the left bracket comes before the corresponding right. So we can see in example 3, it was not valid because we were not having the corresponding right bracket that is of the same type. So that's why that also we have to check. Now it should have same number of opening brackets. So that means that at last we should not be remaining with any bracket which doesn't have any combination. Then that should be false. So seeing this inferences, can we design our algorithm? Let us see that in next step. So this is the algorithm we are going to follow. So it has two steps. One step will be running in loop and the other one will be checking whether the stack is empty or not. First, inside the loop we have three steps. First, we will be iterating from left to right on the string, and for second, if there is an open bracket, we will be pushing it into the stack. Now, why are we using stack? So let us see this example. So in this example, we can see that we have this bracket. So we're pushing that into the stack, then this. Then we can see that there is a closing bracket. So we have to check with this. There's open bracket, we have to push it, and this is the closing bracket, we have to check with this. So the opening brackets we'll be entering, and now if this is the closing bracket, so this is the thing which we have posted into the stack. So you can see that we are checking the recently entered with the current closing bracket that we have got. So stack works on last in, first out. So last in basically means that we need a recently entered value and that will be popped out first. First out, last in, first out. So the last opening bracket entered should be first popped out and checked. So that's why we need a stack. Now coming to the third step. The third step, if any closing bracket, then yes, we'll be popping it out from the stack, and sorry, we'll be taking it from the string and popping the from the top of the stack. So whichever the open bracket is, and comparing it if it's a correct valid combination, and then this loop will be running. So we'll only proceed if it matches correctly, and then we'll be proceeding further. But after coming out of the loop, if the stack is empty, then definitely it's a false case. Sorry, if the stack is empty, then it's true case. This means the full string is valid. There is no combination that is remaining. So that's why if the stack is empty, it's true. Let us try run with one example. So, okay, let us start. So first we have opening bracket. So we'll be pushing it in the stack, and this is my stack. So this is a bracket that we have pushed. Now again, it's a opening bracket. So I will be pushing it, and then there is a closing. So I have to compare. I have to pop out this, and I'll compare, is it similar to this? Yes, it is. So I have to pop it out and I'll proceed. Now there's an open bracket. So there's open bracket. So I'll again push it into the stack. Now there is again a closing. So yes, the corresponding is true. So that's why I'll pop it out from the stack as it is correct. I'll proceed again with the loop. Next character is this. Next character is this closing. So I can see that there is already one combination at the top of the stack. So if the stack would have been empty, then definitely we have to return false. So as we already have this bracket, so it's true. So we'll pop it out. So if we pop it out, so this means now the stack remains empty. So we'll come out of the loop and we'll see that, okay, yes, the stack is empty. So this is true. Now let us run the example 2. Input 2. So we have an open bracket. Let me take a highlighter. Okay. So we have open bracket. So we take it, and then again we have open bracket. Again we push it into the stack, and we have a closing bracket. So we'll check if we have a similar open bracket. So we don't have, it's not similar to that. So that's why we are not going to pop out, and we'll see that, okay, it's a false condition. So that's why we have to return false, and the answer will be false. So that's how we'll be iterating our algorithm. Now talking about the next step. In the next step, we'll be seeing the Java code for this algorithm. So following is the Java code for valid parenthesis problem. We can see that we have a stack, which will be storing all the opening brackets, and we are iterating full string, and then we are taking the ith character, and if it's an opening bracket, we are pushing it into the stack, and let's say if it's a closing bracket, so we are checking if the stack is empty, then it's a false case, and if not, then pop out the recently added element and check if it's corresponding opening bracket. If not, then return false. Otherwise, proceed if it's a proper combination, but we have to pop it out because then only the next opening bracket would come at the top in the stack. At last, we will be checking that if the stack is empty, and then only it will be true. So this is our Java code. And in the next step, let us discuss about the complexity for this code. If we see the time complexity, we can see that the time complexity is big O of n, because we are only iterating a for loop once, and that is from starting till last of that string. So that's why here the n represents the length of the string. That's why the time complexity is big O of n. Now coming to the space complexity, so it's also big O of n. Why? Because in the invalid case, there can be all opening brackets. So stack is only used for storing the opening brackets, and that can be of n length, that is the length of the string in invalid case. While in the valid case, there will be n by 2 brackets, because there will be n by 2 closing. So that's why only n by 2 are needed to store it in the stack. So that's why in the valid case, it would be big O of n by 2, which brings down to O of n, big O of n. So that's the space complexity. So this was our explanation about valid parenthesis. If you remember, in the longest valid parenthesis problem, I said that the valid parenthesis is a variation of it. Now, why it's variation? Let us compare both of them and see. So in both of them, first of all, we are iterating a full string. So we can see that by seeing that we have a for loop that is going from I equal to 0 till n, that is the length of the string. Now, there is a if condition in which there is an opening bracket and some logic, closing bracket, some logic. So the same thing we are doing in valid parenthesis. There is an opening bracket, we are doing some logic. There is the else part, which basically refers to the closing, and we are checking if it's a valid combination. So we can see that the structure is same, but the logic is a little different. And in longest valid parenthesis problem, we use two loops, because there was also a substring that we have to check every time. But in valid parenthesis, it's a full string that we have to check. That's why the one just in one loop we can get our answer. So that's why most of the parenthesis problems are variation of each other, and in the later videos we will be comparing them. So if you liked our explanation, do hit like and subscribe our channel. Till the next video, thank you.